all about confidence. So, good afternoon, ladies and gentlemen. My name is Dr. John Belkowitz. I'm the Director of R&D in Intelligent Concrete. It's an awesome place to work. We just got done playing some basketball, making some real-time decisions. I won. Score! So anyway, had a quick discussion today, but it brought up an absolutely awesome topic. Can we use aggregate that has a high absorption to it as an obstacle, or convert from an obstacle to an opportunity? So can we use it as a benefit? Because oftentimes, especially in the Western U.S. business unit towards the West Coast, and maybe some parts in the Midwest, North Midwest, there's some aggregate that has a very high absorption to it. When I say high absorption, I mean stuff that's really over a 1.4% of an absorption. And to give you an idea what absorption is, oftentimes a rock, it has a porous matrix to it. Whether the rock is alluvial, it's been pushed around by water or wind, and it's got this rounded look to it, or it's a crushed or manufactured rock, it's going to have a certain amount of pores in it and pore structure. And what that makes the aggregate do is absorb a certain amount of its own body weight and the weight of water. Oftentimes, this causes problems, especially when we have a very high absorption. We like rock would normally have a low absorption to it when it's on high absorption. If that rock isn't already prematurely saturated, it can monopolize not only water, there's high fines normally because high absorption material is manufactured material, so if it also has high fines, it'll monopolize even more materials and can cause problems with the efficiency of admixture. So that's the problem that it can cause, and how that relates to a practical job site is it reduces the ability for that concrete to roll down the street. It's no longer a creamy and dreamy mix if it was originally designed, and your slump normally is a lot tighter, especially if that aggregate is bone dry. So how do we turn that obstacle into an opportunity? And that absorption, I mean, we already use that concept when we're working with expanded clay shell or expanded soda lime borosilicate for lightweight aggregate, especially if we're going after internally cured concrete. Take this aggregate that has a very high absorption and we pre-soak it either with water or colloidal silica and then mix it into the concrete, and that internal water is going to contribute to a better interfacial zone between the aggregate surface and the body or the hydrated cementitious matrix interface, and by enhancing that ITZ, you will cause a better composite overall, where you're going to see better compressive strengths, aggregate being locked in, so you should see better flexural strength overall. Anything that relies on that composite structure where you have that, forces get exerted not only on the glue but also get transitioned over to your aggregate, you get a better material that's going to be stronger and last longer. Especially if you're looking at it from a durability standpoint, that you're creating a better interfacial zone, especially when it comes to alkali silica reactivity or something of that effect that, reacts at that interfacial zone. Hopefully you learned something. It was a really interesting topic. Let me know if you got any concrete questions, concrete concerns. Have a great day. Go concrete! Beat asphalt!